This video is going to cover Section 1.10, Modeling with Functions, and the target is that you can write an equation or write a function given verbal descriptions, meaning you can write an equation from a word problem. Now I know you don't have a note sheet for this, but the back of your packet should mostly be blank on that last page, and this is going to be a very short video with only a couple of examples. The first thing that you should be able to do is convert an English sentence into an algebraic equation. So anytime you're reading a word problem, there are some keywords that you want to look for that'll determine what operation you're going to be using. Are you going to be using addition, subtraction, multiplication, or division? So here are the keywords that you'll want to use addition for. Plus, sum, total, more than, combined, or increased by. If you see the following words, you'll want to do subtraction: minus, difference, change, less than, remaining, or decreased by. With multiplication, you'll see the words product, times, per, which also can be used for division. Of would be with fractions, decimals, and percents. And then also if you see the words twice or triple. And then last would be division. The keywords that you'd want to look for would be quotient, goes into, there's per again, and then half, third, and fourth. The difference between the two pers, if you, let's say you make $7 per hour for X hours, that would be 7 times X. But then let's say you are driving in a car and you drive 15 miles per 30 minutes, then that would be 15 divided by 30. That would be an example of division using the word per. And then also you want to look for keywords of when to use an equals sign. The equals sign would be if you see the words is, are, was, were, will be, gives, or yields. And so you'll want to use these when reading word problems and converting English sentences into an equation. And so I just have one short example here. It says almost every word in the sentence will be represented by a number or symbol in the equation. So for example, I wrote $10 was 2/3 of the total money spent. So the 10 is represented by 10, was is the equal sign, 2/3 of, this is where it represents multiplication, and then just total money spent. So then it looks like 10 equals 2/3 times m. And then just make sure you are reading the problem carefully and that your equation makes sense. And that your answers also make sense. So here's a couple of examples. So let's say Sprint's long distance plan has a monthly fee of $20 with a charge of 5 cents per minute for all long distance calls. It says express the monthly cost for Sprint's plan as a function of the number of minutes x of the long distance calls in a month. So f of x is going to be like our y, and then we're going to have equals, and it says that we are charged a monthly fee of $20 with a charge of 5 cents per minute. Well, since x represents our minutes, it's going to be 5 cents or 0.05 times x, and then plus 20. That would be our y-intercept. Sometimes people would think that the 20 should be multiplied by something to represent the months, but since this represents a month already, a monthly cost, we don't have to have 20 times each month. Then we're going to use that equation to answer questions. So then it says how much would 450 minutes cost? Now pay attention to units. Is 450 minutes, is that represented by the y or represented by the x? And since in the problem it said x was minutes, we're going to plug the 450 in for the x and then solve from there. And we get $42.50. The next question I have is, if you had a bill that was $100, how many minutes did you use in a month? So since this is $100 and f of x represents the monthly cost, we're going to plug 100 in for f of x and then solve for x. So we get 100 equals 20 plus 0.05x, subtract 20 from both sides to get the 80 equals 0.05x, and then divide by 0.05, and then you should get 1600 and then minutes. Now it's really important that you put your units on these word problems. The next part is Verizon's long distance plan. Let's say that they have a monthly fee of $5, but they charge 10 cents per minute for long distance calls. It says express the monthly cost for Verizon's plan, g of x, as a function of the number of minutes of long distance calls in a month. So it'll look similar to the Sprint's. Our y-intercept is 5, that $5 monthly fee, and then 10 cents per minute. Now it says the next question, it says how many minutes of long distance calls will the cost for the two plans be the same? So being the same, that means we want to set our two equations equal to one another and then solve for x because we're solving for how many minutes. So then we're going to subtract 5 from both sides, subtract 0.05x from both sides to get 0.05x equals 15, and then we have to divide by 0.05 to get 300 minutes. And then the last question, it says what is the cost? Now since this is when each plan is equal to one another, we can plug the 300 either into the g function or into the f and you should get the same value. So I just plugged it into g and I got $35. The last example for a word problem that I have is regarding perimeter and area. It says you have 140 yards of fencing to enclose a rectangular garden. Express the area of the garden, A, as a function of one of its dimensions. Now you're probably wondering how can we write area as a function of one of its dimensions. So first we're going to write the area formula for this rectangle, A equals x times y. But I gave you some information that's going to help us to rewrite this equation so that we only have an x value. So first thing is talking about the perimeter. I said that you had 140 yards of fencing. This represents perimeter, not area. If it had been area, it would have been yards squared. So perimeter equals 2x plus 2y. So now I'm going to plug that 140 into the equation. And since I want to rewrite my area just in terms of the x variable, I want to rearrange my perimeter equation so that I get y by itself, because then I'm going to substitute it into the area problem. So I'm going to subtract 2x from both sides, and then I have to divide by 2. So I get y to be 70 minus x. Well, now I'm going to substitute this in for the y of the area formula, and then I'm going to simplify, and we get that area equals 70x minus x squared. And now we have area just in terms of one variable. So these were just a couple of examples of word problems that in this chapter. We will be seeing a lot of word problems coming up in Chapter 2 and in Chapter 3. And I just kind of wanted to get you back into the swing of reading word problems and converting those sentences into equations. So this covered Section 1.10, Target 1.13.